Welcome to the Deep Dive, where we unpack the most fascinating sources to give you a shortcut to being truly well-informed. Today, we're diving into something that honestly sounds like science fiction, but is very much real. Imagine an AI sales representative capable of sending, get the 50,000 personalized emails a day.
Wow.
Yeah, think about that. A human sales development representative, an SDR, they might manage, what, 20, maybe 50 emails in the same time?
It's a staggering difference. Just the scale is hard to comprehend.
Exactly.
And our mission today is really to pull back the curtain on how companies are using this kind of cutting-edge AI to create these, well, digital workers.
We're going deep into the brain behind Alice. She's an AI SDR from a company called 11x.
Yeah.
We want to understand how Alice actually learns about businesses, about customers, sort of like a human does, but at this unbelievable scale and speed.
And what's really cool is our insights are coming straight from the source, right? This is from a talk by the actual tech leads at 11x.
They focus specifically on the engineering behind Alice's core intelligence, her knowledge base. So we're getting a real look under the hood.
Precisely. So what you'll learn today is, first, the fundamental problem. How does an AI get to really know complex business stuff? Then we'll walk through this pretty intricate 5-step process they built for Alice's learning system. It's fascinating stuff. We'll even look at the surprising ways they visualize this AI knowledge, like literally letting you peek inside her brain.
Okay, that sounds cool.
Yeah, and finally we'll cover the key lessons, some quite unexpected, that they learned from this really groundbreaking project. Basically, this deep dive gives you a shortcut to understanding this intersection of AI, sales, and just massive data processing.
Okay, let's get into it. We mentioned SDR just now. For anyone maybe not deep in the sales world, can you quickly define what a sales development representative actually does? What's their job?
Sure thing. Yeah, an SDR is typically an entry-level sales role. Their main focus is generating new leads for the business. So their core tasks usually boil down to 3 things. First, sourcing leads, finding the right people or companies. Second, contacting and engaging them, email, LinkedIn, other channels. And third, the big goal, booking introductory meetings for a more senior salesperson, like an account executive.
And they're measured on replies,
Yeah.
meetings booked.
Exactly. Key metrics are usually positive replies, and most importantly, those successfully booked meetings. A lot of their day is about crafting that personalized outreach.
Got it. And Alice, she's 11x's AI version of that SDR, working alongside another AI, Julian, who does voice.
That's right. But Alice handles the email outreach, and the scale, as you said, is just mind-blowing. 50,000 emails daily versus maybe 50 for a human.
And she's not just doing this for 11x itself, right? She's running campaigns for loads of different companies.
Yeah, roughly 300 different business organizations are using her right now. It's pretty extensive.
Okay, before we go deeper, maybe a quick clarification on terms. It can get confusing talking about AI selling things.
Good point. Yeah, it's important. When we say seller, in this context, we mean the company using Alice, so 11x's customer.
Right. The business whose products Alice is promoting.
Exactly. And when we say lead, that's the prospect, the person or company being sold to.
Seller uses Alice to sell to the lead. Got it.
Perfect.
So for Alice to do this job well, especially at that volume and with personalization, what does she absolutely need to know?
There are 2 critical buckets of information. First, she absolutely has to know the seller. That means really understanding their products, their services, case studies, the specific pain points their product solves, their unique value propositions, who their ideal customer profile, their ICP is, all that stuff.
Okay, knowing the company she represents, what's the second part?
Second, she needs to know the lead. Their specific job title, what are their responsibilities, what keeps them up at night, their concerns. Also, what solutions might they have tried before? What are their pain points? And details about the company they work for.
Makes sense. You need both sides for effective personalization.
Absolutely. But for this deep dive, we're really going to focus mostly on that first part. How does Alice get to know the seller?
Okay, so that's the goal. But I'm guessing they didn't just jump straight to this advanced AI brain. What did they try first?
Yeah.
The old way. What didn't work?
Right. Their initial system, they called it the library, and it was very manual. Sellers had to physically go into a dashboard and type in all the details about their products, services, pain points, value props, define every single offer.
So the seller had to feed Alice all the context manually.
Exactly. They'd write these detailed descriptions for each offer, and those descriptions were what Alice used as context when she was writing her emails.
That sounds laborious.
It really was. That was the first major drawback. It was incredibly tedious, a really bad user experience, frankly. just tons of manual data entry.
And that probably slowed things down.
Massively. It created huge onboarding friction. Users couldn't even launch their first campaign until they'd painstakingly filled out this entire library.
Ouch. Any other problems with that manual library?
Yeah. The other big one was that the emails Alice produced were often suboptimal because the user had to decide up front which offers to give Alice context on. So either they picked too few offers and Alice didn't have enough relevant info for a specific lead.
Or they picked too many.
Right. They picked too many, and it overloaded Alice's context window. That's the limited amount of info an LLM can kind of juggle effectively for one task. Too much irrelevant stuff diluted the message.
So either not enough info or too much noise.
Yeah.
Neither is good for personalized emails.
Precisely. It just wasn't effective enough.
So they hit this wall.
Hmm.
And then presumably there was a sort of aha moment, a shift in thinking.
Exactly that. The big idea, the aha moment, was realizing instead of the seller having to manually push all this context to Alice.
What if Alice could just go get it herself?
Exactly. What if Alice could proactively pull all the relevant information into her own system? More like a human researcher would, you know?
So that's a fundamental shift.
It is. And that led directly to developing the knowledge base. The goal was to make Alice more like a human SDR. You might hire, you give them a stack of company documents, maybe access to the website, sales call recordings, and they just learn over time.
Instead of being spoon-fed pre-selected snippets. Much more scalable, I imagine.
Way more scalable and potentially much more comprehensive.
Okay, so this knowledge base is the solution. How do they actually build it? What does Alice's brain look like from a high level?
So the knowledge base is basically a central hub on the 11x platform. It holds all the information about a particular seller. The core idea is users can just dump all sorts of source materials into it. We're talking marketing brochures, internal docs, case studies, sales call recordings, press releases, pretty much anything.
Any format, PDFs, websites, videos.
Yeah, they categorize the inputs into three main types for processing. Documents and images like PDFs, PowerPoints, websites, just URLs, and media, audio and video files.
Okay, and how does that stuff actually get processed and become useful knowledge for Alice? What's the technical flow?
So at a high level, it starts when a user uploads a resource, let's say a PDF, through the web interface. That file first gets stored in S3, Amazon's cloud storage, just raw storage for the file.
Right.
Then that triggers a notification to their backend system. The backend creates records in their main database and initiates specific jobs based on what kind of file it is. Now, for the complex part parsing, they use external vendors. These vendors work asynchronously, meaning 11x doesn't wait for them directly.
Okay, so they outsource the heavy lifting of understanding the files.
Pretty much. When a vendor finishes parsing, say, that PDF, they send a webhook back to 11x. That's just an automated message saying, hey, I'm done, here's the data.
Right.
11x's system then consumes that parsed data. It stores the text in their own database, but crucially, it also upserts it, which means update or insert.
And embeds it into Pinecone. Can you unpack those two terms, embedding and Pinecone?
Sure. Embedding is a key AI concept. It's transforming text into numerical representations vectors. Think of it like giving each piece of text coordinates in a high-dimensional space.
So the AI can understand meaning and similarity mathematically.
Exactly. Texts with similar meanings end up with similar numerical vectors close together in that space.
And Pinecone?
Pinecone is a specialized vector database. Its whole purpose is to store these embeddings and perform incredibly fast similarity searches. Find the most relevant pieces of text based on meaning, not just keywords.
Okay, so the parsed text gets turned into vectors and stored in Pinecone.
Right. And once that's done, Alice's agent system can query Pinecone to find the most relevant information when it needs to write an email.
Wow, that's quite a pipeline just to get information ready. You mentioned 5 key steps in this learning process.
Yes, the core steps they outlined are parsing, chunking, storage retrieval, and then one that sounds a bit unusual but is vital, visualization.
Let's break those down, starting with parsing. What's involved there, and why is it the first step?
Parsing is all about conversion, taking non-text stuff, PDFs, videos, images, websites, and turning it into structured text. Why? Because large language models, LLMs, the brains behind AI, like Alice, they fundamentally operate on text. You have to feed them text they can understand.
So you need to translate a PowerPoint slide or a video into text.
Precisely. And their target format is Markdown. It's a simple text format that keeps important structure like headings, lists, bold text, which gives the LLM more semantic context than just plain flat text.
Okay, makes sense. Now, parsing sounds really fundamental. Why didn't 11x just build their own parsers? Why rely on outside vendors for something so critical?
That's a really good question, and they had solid reasons. First off, complexity. Just think about all the different file types and formats out there. PDFs with weird layouts, complex websites, different video codecs. Building robust parsers for everything is a massive task.
Yeah, that sounds like a whole company in itself.
It is, which leads to their second point, speed to market. They wanted to get this knowledge base feature out quickly. Getting bogged down trying to perfect parsing for every edge case would have taken ages.
And the third reason.
Specialization. As you said, there are companies that only do parsing. They have dedicated teams just focused on that. 11x realized their core engineering team shouldn't become parsing experts. They should focus on the AI and the sales application. Leveraging vendor expertise made more sense.
Okay, practical decisions.
Yeah.
So when they were choosing these vendors, what were they looking for, and did they miss anything initially?
Their main requirements were pretty clear. Does the vendor support the file types we need? Can they output clean Markdown? And do they have good webhook support so we can get the data back easily and automatically?
Seems logical. What were the blind spots?
In hindsight, they admitted they didn't initially focus enough on accuracy and comprehensiveness. Like, how well does the parsed text actually match the original? Is it missing key tables or paragraphs? They kind of assumed the market leaders would be good enough.
And cost.
Cost was another one they didn't scrutinize heavily up front. Because it was pre-production, they didn't have real usage data to predict costs accurately. They planned to optimize later, but it meant they didn't have a full picture of performance versus cost early on.
Okay, understandable trade-offs when you're trying to launch something new.
Right.
Which vendors did they end up picking for the different types of content?
Right. For documents and images, things like PDFs, Word docs, PowerPoints, they chose LlamaParse. It's a product from Llama Index.
Why LlamaParse?
Key reasons were it supported a really wide range of file types, and apparently they had great customer support. They mentioned getting quick help via shared Slack channels, which was a big plus. It could take a sales deck PDF and output nicely structured Markdown.
Oh, what about websites?
For websites, they went with Firecrawl. They said they were already familiar with it, which helps. And a key feature they wanted from a competitor, Tavi's crawl endpoint, wasn't ready yet. So Firecrawl let them basically give it a URL, and it would crawl the site and return Markdown.
And audio video. That seems tricky.
Yeah, for audio and video, they chose a vendor called CloudGlue. This was interesting. They picked them because CloudGlue handled both audio and video files, and crucially, CloudGlue didn't just transcribe the audio. It could also extract information from the video content itself, like scene changes, maybe text appearing on screen. That gives richer context than just a transcript.
Oh, interesting. So it understands the visuals too, not just the sound.
Apparently so. Turning, say, a YouTube product demo into Markdown with more than just spoken words.
Okay, so step one, parsing, gets everything into structured Markdown text using these specialized vendors. What's step two, chunking? Why break it down further?
Right. So after parsing, you might have these massive Markdown documents, maybe a whole website crawl or a long transcript. That's too big to effectively feed into the next stage, the embedding in vector database. So chunking is about breaking these large blobs down into smaller, more manageable pieces or chunks. But the key is doing it semantically.
Meaning preserving the, well, meaning.
Exactly. You don't want to just randomly chop the text up. You need to protect the structure that Markdown provides. A heading is different from a paragraph. A list item is distinct. You want to keep logical units of meaning together within a chunk.
How do you do that? What methods did they look at?
They considered a few strategies. You could split based on a fixed number of tokens, the smallest text units AI uses, or split by sentences, or more structurally, split based on Markdown elements like headers. Some even use an LLM itself to figure out the best split points.
What did 11x land on?
They went with a hybrid approach, kind of layered. First, they try to split based on Markdown headers to keep sections intact. If chunks are still too long, they split by sentences. And if those are still too long, they fall back to splitting by tokens.
So a hierarchy of rules to keep structure but ensure chunks aren't too big.
Precisely. It helps preserve the meaning for the AI and also makes the chunks suitable for displaying back to the user in the interface, which we'll get to. It stops chunks becoming so long that the core meaning gets diluted when it's turned into a vector embedding.
Okay, makes sense. So now we have these nice, semantically meaningful chunks of text. Step three, storage. Where does all this knowledge live?
Right, storage. Now, when people talk about RAG retrieval augmented generation, they often jump straight to vector databases. And 11x does use one, But it's worth remembering, RH technically just means retrieving context from any external source to help an LLM. That could be a graph database, a normal SQL database, even just files in S3.
But 11x specifically chose a vector database.
Yeah.
Why?
They chose a vector database, Pinecone in their case, because it's purpose-built for that similarity search we talked about. Finding relevant information based on semantic meaning, using those vector embeddings, is exactly what vector databases excel at. It's super fast and efficient for this kind of lookup.
And why Pinecone specifically? You mentioned it earlier.
Yeah, they chose Pinecone for a few reasons.
Mm.
One, it's a well-known market leader, which gave them confidence, especially starting out. Two, it's cloud-hosted, which meant less infrastructure headache for their team. They didn't have to manage the database servers themselves.
Easier to get going.
Definitely. They said it was easy to start with, good documentation, good SDKs. Plus, Pinecone actually bundled embedding models, so they didn't need yet another vendor just to create the vectors.
Oh, convenient.
Yeah, and again, they mentioned really good customer support from Pinecone, helping them think through things, even future possibilities like using graph databases alongside it.
Okay, so parsing, chunking, and storing in Pinecone.
Yeah.
Now, step 4. Retrieval. This is where Alice actually uses the knowledge base, right? How does she find the right info for an email?
Exactly. Retrieval is the R in Erga. And this is where things have gotten really sophisticated. It's not just a simple lookup anymore. Think about the evolution. You had traditional RAG, which was basically ask a question, do one quick search in the vector database, grab the top results, stuff them into the LLM prompt, and get an answer.
Okay, simple retrieval.
Then came agentic RAG.
Yeah.
Here, the LLM acts more like an agent with tools. It could decide to use the retrieval tool multiple times, maybe ask follow-up questions based on initial results. More steps involved.
Getting smarter.
Right. But 11x is doing what they call deep research RAG. This
Yeah.
is kind of the next level. The AI agent acts much more like a human researcher.
How so?
It creates a plan first. It might decide it needs to perform multiple retrieval steps, perhaps searching broadly first, then diving deeper into specific areas based on the lead's details. It can even evaluate if it has enough information or if it needs to search again.
Wow, so it's formulating a research strategy on the fly.
Sort of, yeah. It's much more dynamic and intelligent than just a single query.
And how did they build this deep research agent?
They built it using Lida, which they described as a cloud agent provider. So Lida helps manage the agent's planning and execution. The process looks something like this. The agent gets the lead's info, it formulates a plan, maybe step 1, find case studies relevant to this lead's industry. Step 2, find value propositions related to their job title. Then it calls the necessary tools, which query the Pinecone knowledge base. It gets the results, summarizes them internally, and then uses that synthesized information to generate the final personalized email.
That is seriously advanced. It really is like mimicking a human research process.
It's getting much closer, yes. Much more nuanced retrieval.
Okay, that brings us to the 5th step. The one you said was a bit untraditional for a data pipeline. Visualization. Why is seeing inside the knowledge base so important?
Yeah, it sounds odd, right? Visualization in a data pipeline. But for 11x, it was absolutely critical, primarily for building customer trust.
How does visualization build trust?
Think about it. Sellers are letting this AI, Alice, represent their company, talk about their products, mention case studies. They need to be sure Alice actually knows what she's talking about. They need reassurance that she isn't just going to hallucinate, make things up, or misrepresent their offerings. Without transparency, users would be terrified to let her send 50,000 emails.
Okay, I see. Fear of the AI going rogue or just being wrong.
Exactly. So they needed a way for users to see what Alice knows and where she got that information from.
And how do they achieve that? How do you visualize AI knowledge?
They built a really cool interactive 3D visualization right into their product's interface. Basically, they take all those vector embeddings stored in Pinecone and project them down into a 3D space. Each vector becomes a visible, clickable node.
So you can literally see the knowledge base as a kind of 3D map.
Yeah, sort of like a galaxy of information points. And users, not just the customers, but 11x's own sales and support teams too, can navigate this 3D space. They can click on any node, any point, and see the actual chunk of text associated with that vector. It's a direct way to peek into Alice's brain and see the source material.
That's brilliant. So you can verify what she knows.
Precisely. And they integrated this transparency elsewhere too. When a user uploads resources, documents, URLs, videos, and clicks Learn, they can see that content populating the knowledge base. And then when they're setting up an email campaign, the interface shows a sort of Q&A section based on the knowledge base. Users can click on questions like, what case studies are relevant, and see the exact chunks of text Alice retrieved and used to generate her messages.
Full transparency from input to output.
That's the goal. It demystifies the AI and builds that essential trust. Users feel more in control because they can see the why behind Alice's emails.
That 3D visualization, has that been well received? It sounds like a unique selling point.
They indicated it was incredibly well received. It really helps users, especially non-technical ones, grasp what the AI is doing. It moves it from being a black box to something they can actually inspect and understand. It also helps them troubleshoot. If Alice isn't saying the right things, they can look at the visualization or the retrieved chunks and realize, oh, maybe I haven't uploaded the right document covering that topic.
So it aids debugging and improves the knowledge base over time, too.
Exactly. It's been key for adoption and confidence.
Fantastic. So reflecting on this whole journey, building this complex knowledge base, this AI brain, what were the big takeaways for the 11X team? What did they learn?
Well, first off, they emphasized it was a truly revolutionary project for them. It massively improved the user experience compared to the old manual library, and it really pushed their team's skills forward. But they shared 3 key lessons learned. The first was just how complex RAG really is. They said it was way more challenging than they initially anticipated.
More than just plugging into vector database.
Oh yeah, much more. It involved countless micro decisions, how to handle weird PDF formats, how to best preserve meaning during chunking, evaluating different embedding models, choosing vendors. All these little things add up to a really intricate system. It underscored just how much goes into building robust AI knowledge systems.
Okay, lesson 1. RRED is hard. What's lesson 2?
Lesson 2 is very practical. Get to production before benchmarking.
Meaning,
Don't get stuck endlessly trying to perfect everything in a lab environment. Their advice was to prioritize getting a functional system, one that meets the core requirements, out into the real world, into production, because that's where you get real usage data. That's when you can truly establish meaningful benchmarks for things like parsing accuracy, retrieval relevance, and cost. You can't effectively optimize in a vacuum.
makes total sense.
Yeah.
Avoid analysis paralysis, get real feedback.
Exactly. Don't let perfect be the enemy of good, especially early on.
And the third lesson,
The third was lean on vendors. They strongly advised leveraging the expertise of the vendors you work with. These companies specialize in their niche, whether it's parsing, vector databases, or AI agents. They're competing for business, so make them work for it.
how so?
Challenge them, ask for demos, make them explain why their solution is better. Get them to provide support and insights. You can learn a lot from them and avoid reinventing the wheel yourself. Don't be afraid to push them.
Good advice. Use the ecosystem.
Right.
So, with all that learned, what's next for Alice's brain?
Yeah.
What are 11X's plans for improving it further?
They outlined a few key areas. A major ongoing focus is tackling hallucinations. They want to get much better at tracking instances where Alice might make up information in her emails and figure out how to eliminate those. That's crucial for trust.
Absolutely. What else?
They also plan to revisit their vendor evaluations, specifically for parsing. Now that they have production data, they want to go back and properly benchmark vendors on accuracy and comprehensiveness, those metrics they kind of deferred initially.
Closing the loop on those early blind spots.
Exactly. They're also interested in exploring hybrid RAG, specifically experimenting with adding a graph database alongside Pinecone.
Why a graph database?
Graph databases are really good at understanding relationships between entities. Combining that with Pinecone's semantic search could potentially allow for even richer, more nuanced information retrieval. Understanding how different products relate to different customer types, for instance.
Interesting. More complex knowledge representation.
Potentially, yeah. And finally, just the continuous grind of cost reduction, optimizing every step of that pipeline, parsing, embedding, storage, retrieval, to make it more efficient and less expensive to run at Alice's massive scale.
Always important at scale. Well, this has been a fascinating look under the hood. This deep dive into Alice's brain really provides a concrete example, a blueprint almost, for how AI can absorb, process, and apply huge amounts of information in very practical ways. It's way beyond simple automation.
It really is. It shows the level of sophistication involved in building these kinds of truly intelligent digital workers that can perform complex knowledge-based tasks.
So for you listening, think about this, the deep research agent approach, where AI doesn't just fetch facts, but actively pulls, synthesizes, and plans its knowledge gathering. How could that transform other fields? We see it here in sales, but imagine it in scientific discovery, analyzing research papers, or in strategic planning, synthesizing market reports, maybe even just optimizing your own personal learning. What other complex brains do you think AI is building right now, maybe quietly, that could fundamentally change how we interact with information and make critical decisions in the future? Something to think about.